Hi everyone, my name is Jin and I'm a junior software developer at one of the big tech companies known as The Flag. Today I want to share 5 most important computer science courses and why you should take them if you consider tech as your career. Right now I have started my job a couple months ago and I learned tons of new stuff at work every day, things I never heard of at school. Nonetheless, university courses prepared me with the mindset and buildstones of learning effectively at work. And today I want to share these courses with you. This list, by the way, is by no means complete. So the first one is data structure and algorithms. What is algorithm? It's essentially a procedure or steps that you want your computer to follow in order to complete a task you defined. What is data structure? It's some smart way to store your data so that you can do certain operations faster than if you do them just naively. It's very often also trade-offs between space and time if you want to be able to, say, search or delete some data in your storage very quickly. You will have to put more space into storing these pieces of extra information that allows you to do so. You will also learn the big O notation, and that's how you uniformly measure the efficiency of your data structure and algorithms. It may sound abstract and far-fetching, but the choice of algorithm and data structure makes a lot of difference when your application is about to scale. That's when you are not dealing with only 100 inputs, but say 10,000 inputs, and you don't want the users, which could be you, to wait for an hour for the output, and nor do you want to run out of memory all the time. The second course is design patterns. For example, there are a lot of them like
object-oriented programming, publish, subscribe, factory method, singleton, and so on.
The most important and basic one, however, is object-oriented design. It is the most likely you will encounter in either your interview or your actual jobs as a junior software engineer. Object-oriented design is when you have functionalities or properties that are interconnected by some natural logic. And then you would naturally want to represent them in a way that reflects those relationships. You would avoid having a lot of functions here and there, and things become very messy when you have, say, 20 functions. In object-oriented design, you would create objects with its own states and methods, have control over how other programs tangle with your objects. There are too many design patterns and each have their own use case. I will make another video into just going through all of them, but they are more advanced, while object-oriented design is the most basic and fundamental. The third one is software systems. You've probably heard of
Linux, bash, shell, SSH, which is server, etc.
You need to know how we, as a human, interact with the computer. It's through what's called the command line, and the shell is the interface between us and the operating system. Server is also a very broad word that you probably have heard tons of times. It just means that a set of computers or programs that are ready to perform tasks and communicate with other computers, as known as the clients. As a software engineer, you probably will have to work with a server at some point, which is usually going to be a Linux machine, and may or may not have a graphical user interface for you to move your mouse around and click on stuff. That's when Linux commands, bash scripts are very useful. You want to learn how to talk to your machine by typing commands, how your server communicates with its clients and how you can observe that communication, and also how information flows around the world in general. The fourth course is operating systems. In your third year, you probably have already built up some knowledge about computer, software, and having some experience in coding. Many of you may want to learn more about your machine, the operating systems, the memory controls, how the kernel schedule all different tasks. In this course, you will learn about all of them, the file system, how the kernel schedule processes and tasks, and you will also code a lot in programming language called C. It's good to get familiar with C-style language where you have to manage memory yourself so that you won't freak out when dealing with some non-garbage collected language in your work. I probably have said too much jargon, so let me explain. Most languages like Python, Java, etc. has a garbage collector within the virtual machine that your code runs upon. So you don't need to worry about any classes you create in your code. When the program goes out of the scope and no object is referring to them, The garbage collector inside the virtual machine will automatically delete them, but it is not the case with C or C++. You have to be responsible and remember to destroy all the memories that you allocated for your object. Garbage collector makes sure that when you exit your program, you don't leave some data on the memory where the same physical slot will be used by some other programs later. Oh, another important thing is to get a bit of taste of concurrent programming. Synchronization is a very big deal in complex programming. Finally, the last but least, networks and/or distributed systems. When you become a little bit more senior, you may be curious of how information actually flows around the world, how you can browse a website in another continent, how you can send and receive email to someone from far away. Magic doesn't happen, and every piece of information has to go through the fiber, and you will learn all about this process. You also learn about ways how to send information through what's called TCP or UDP. And on top of TCP, you also have a different protocol called HTTP. And that is the protocol you use to browse a website and ask for some third-party API for information. Networks are just millstones of how information flows. Maybe you also wonder what happens if your service needs to handle a tremendous amount of information and tasks. This technique is known as the cloud, where instead of having an expensive computer with huge memory and CPU power and you hope that it never crashes, you can use the same money and get a bunch of cheap computers with just so-so hardware, but incorporate them together by some algorithm so that the whole system never crashes. That's where distributed systems come into play. Computers cooperate with each other so that externally it is just viewed as one system. But internally, some very complicated stuff is going on. You will learn the challenges and the solutions of deploying such a huge system. For example, how to store multiple replications of data but maintaining them all consistent copies. How to consider cases for failures such as network package loss or just machine crash. Course materials might be really hard. It's actually a graduate level course in my university, but it's absolutely interesting and will be very helpful if you are gonna work in a very large company, because that's when nothing is local and you will always be working on the cloud. That's all for today's discussion. As someone who did a research in university lab in the industry and finally today working at a big tech company as a software developer, I hope you find this video useful. What are your thoughts about today's topic? Like, subscribe, and comment below. Share it to your friends if you find it helpful. Let me know in the commenting areas if there's any topic that you want me to cover in the future videos. Bye bye!